we're going to do two types of problems quickly today that you can do. The first I talked about a little bit yesterday. I gave you like a preview because it was just easier to do it that way. The first is direct substitution. If you can plug the number in and get a valid answer, that is the answer. It's called direct substitution. So you always want to try direct substitution first. Okay, so like for example, on this problem, if I do 3 times 2 squared minus 4, I must do order of operations. What should I do first? Exponents. So I'm going to have 3 times 4 minus 4, so 12 minus 4, which is going to give me 8. Okay, that's just your answer. So every problem you want to try to plug the number in first. Example 2, we've got limit as x approaches negative 2. So we're just going to try to plug in negative 2. 6 plus negative 2 underneath the square root. That is going to give us the square root of 4, which is 2. That's your answer. As you can imagine, a lot of the problems you're going to get are not going to be direct substitution because this is too easy, right? But you will get them. And actually, they end up being one of the most missed problems because once we learn to do the harder ones, you forget to check to see if you can do this. And you try to use other methods that don't work there. But if you can plug the number in, that is your answer. Now, 3 is a little tricky. What do you guys think about 3? We're supposed to plug in 0, right? But we can't because there's no x there. So the answer to this one is just 5. This problem, it does not matter what your x approaches. The 5 is just a horizontal line, right? The y value on that line is 5 everywhere. So like I could have the limit as x approaches 8 of 5, and that would still equal 5. Or I could have the limit as x approaches negative infinity of 5, and that would still equal 5, right? It doesn't matter what you're approaching if it's just a constant. It's just, you're just going to get that number. So those are some of those problems that are like so easy that they're hard. So you'll have some problems where you have to do this. But direct substitution does fail sometimes. So direct substitution can fail in 2 different ways. It can fail where the limit does not exist or where you get indeterminate form. Okay? So limit does not exist is going to get you when you have a number besides 0 over 0. So for example here, if you try direct substitution, you are going to get 3 divided by 0. Okay? If you get any number besides 0 over 0, you are going to say does not exist. A little bit later, we will talk about how you can tell if it's going to be like positive infinity or negative infinity. But for right now, just give me a D and E for those. Okay. Technically, if positive or negative infinity are your answer, it's still a D and E, right? That does not exist. Okay. But the other thing that can happen is you can get the indeterminate form. Okay. So if I try to plug in 5 here, I'm going to have 5 squared minus 4 times 5 minus 5 over 5 minus 5. And in the top, that's going to give me 25 minus 20 minus 5. And in the bottom, I got 0. And 25 minus 20 minus 5 is 0 over 0. This is called the indeterminate form. It is not going to tell you that the limit does not exist. It also does not tell you if the limit does exist. It's indeterminate. It tells you nothing. Okay. There are some other indeterminate forms we can have, like infinity over infinity or 0 over infinity. We'll talk about those later. 0 over 0 is what you're going to see on this stuff. if you get the indeterminate when you do direct substitution, that means there's something else you can do to get an answer. That answer still might be does not exist eventually, but there's something else you can do. So, so we could do something else to solve that problem. I'm going to show you just example 4, and then we're going to quit, and then we'll, after you guys finish the quiz, we'll pick back up and finish these notes. But one of the methods that you can try is you can factor and you can cancel. Okay, so you're supposed to try direct substitution every time. If I try direct substitution here, I will have -2 squared minus 3 times -2 minus 10 over -2 plus 2. I can already tell it's not looking good because I got 0 in the bottom. And sure enough, if I do the top, I've got 4. Oh, wait. Yeah, 4 plus 6 minus 10, which is 10 minus 10. This is 0 over 0. So this is indeterminate. And I must try something else. So one of the methods we can try is we can factor and then cancel out things that are on top and bottom. So if I'm factoring x squared minus 3x minus 10, when you're writing this, keep your limit notation. You cannot get rid of your limit notation until you've plugged in a number, which on the other problems was the first thing we were doing, so we didn't write limit notation. But if I'm going to factor x squared minus 3x minus 10, I could use an x and an x. What numbers could I multiply to get -10, but add or subtract to get -3? -5, +2. On the bottom here, I've got x plus 2. What can happen? The x plus 2 can cancel with this x plus 2, which means that now I have the limit as x approaches -2 of x, just x minus 5, right? Can I use direct substitution on this problem? Yes, I can. So once you're, like right now, I have my limit notation. Anytime you still have like a variable there, you need limit notation. But I'm getting ready to plug in the number. So I'm going to drop my limit notation. I'm just going to have -2 minus 5. And I will get -7 for that. Okay, so if you factor and cancel, then on that next step, you can probably use direct substitution to actually get a number answer for that. Does that make sense? Did I print the assignment on the last slide of these? I put the formula for factoring a difference of cubes. Or I should say sum or difference of cubes. It can be a sum or a difference of cubes. If you have a to the third plus b to the third, you will get a plus b times a squared minus ab plus b squared. Or if you have a minus sign, then you'll have a minus here and a plus here. That's basically the only things that change in that formula. Okay, so for this problem, we've got x to the third minus 1. To factor that, we're going to have to use this formula. Actually, I'm getting ahead of myself. What's the first thing you're supposed to do on all limit problems? We're supposed to try direct substitution. But if I try direct substitution here, I'm going to get 1 to the third minus 1 over 1 minus 1, which is 0 over 0, which is indeterminate. And indeterminate tells you got to keep going. You should never give 0 over 0 as your answer. Or like say, oh, 0 divided by 0 is 0. That's false. So never give that as your answer. It tells you to keep on going. So here I've got x to the third. Is it okay for me to like say 1 to the third? Would that still be the same? Yeah. So if I write this way, really my a is like a x, right? So I could just like change all these a's right here to x's, right? And then my b is a 1. So I could change all my, actually, I'm using the wrong formula because I have a minus sign, right? So this is an X, this is an X, this is an X, this is an X, and then all my B's are 1s, like this, right? So to factor that X to the third minus 1 to the third, I'm going to keep my limit notation. I'm not plugging in yet, so I'm going to keep that limit notation. I will have X minus 1 times, and then I'll have X squared plus, I got X times 1, which is just X, and then plus 1 squared, which is just 1. We'll do a warm-up tomorrow where we do a few like difference of cubes just to practice that a little bit more, but you're just using that formula and basically plugging those values in. This one's a really simple one because 1 is 1 to the third, so it's really simple there. We'll do a couple more to get a little more practice with that. So now that I've done this, what can happen? X minus 1s can cancel, right? So that means now I'm just doing the limit as x approaches 1 of x squared plus x plus 1. And I can try direct substitution. Once you plug in the number, that's when you drop the limit notation. So I've kept the limit notation the whole way. And then when I'm plugging in the numbers, that's when I can drop the limit notation. And I'm just going to get 3 for this one. Questions there? Okay, the other type we're going to do today are ones where we have to rationalize the square root. Okay, so before we actually do a limit problem, let's review rationalizing a little bit. So in pre-cal, they did not like for us to leave a square root in the bottom of a fraction. So does anybody remember how we could get the square root out of the bottom of the fraction? Very good. Oh, what happened there? Multiply by root 5 over root 5. Why is it okay to do that? It's essentially 1. Square root of 5 divided by square root of 5 is 1, doesn't change its value any, right? It changes how it looks, but it doesn't change its value. In the top, you're just going to get square root of 5. What is the square root of 5 times the square root of 5? It's just 5, because square root of 5 times square root of 5, you can multiply what's on the inside, right? That's going to give you square root of 25, which is just 5 itself. Or another way you can think of that is you're doing the square root of 5 squared, and square roots and squares cancel each other out, just giving you the 5 right there. Okay, do you guys remember doing that in pre-cal? I did maybe hear a couple of you under your breath saying we could just square it right there. If I square it, I get 1 over 5. Is 1/5 the same as 1 over the square root of 5? It is not. Squaring the top and the bottom does not give you the same value there. So you cannot just like square the top and bottom. The only thing you can really do is multiply by the factor that is 1. Now, if you have a fraction it's telling you to square, you can square top and bottom, but that's a different thing there. So you cannot just square to get rid of it. You got to multiply by that square root. Now, I'm having a hard time remembering if we even did 7. I think it shows up somewhere, but I can't remember for sure. Anybody remember how to get rid of the square root on number 7? You may not have even ever seen it, so I can't remember for sure. So here, it's not going to work to multiply by the square root of 6 on top and bottom because of this 2 over here. Okay, so what you've got to do is we're going to do something called multiply by the conjugate. Okay, so it's basically like a difference of squares. Like if I give you x minus 1 times x plus 1, what does that equal? That'd be x squared minus 1, right? The middle terms cancel out whenever you have that plus and that minus. That's what we want to happen here. We're going to have 2 minus the square root of 6. I'll show you, we'll see in a minute why this works. Okay, can I just multiply the bottom by 2 minus the square root of 6? I cannot. I must also multiply the top by 2 minus the square root of 6. Because 2 minus the square root of 6 over 2 minus the square root of 6 just equals 1, so we're not changing the value of anything. Okay, so here's the reason we're choosing that. It's called the conjugate, and here's the reason we're choosing it. In the top, we're just going to leave that alone. I'm just going to call it 8 times 2 minus the square root of 6. I'm not going to mess with the top. But in the bottom, what I want to do is I want to distribute here. So I'm going to do 2 times 2. That will give me 4. Then I've got to do 2 times negative square root of 6. Can I multiply the 2 and the 6 together? I cannot because one's under the square root and one of them is not. So I just have to write it this way. Minus 2 times the square root of 6. Okay, so I distributed the 2. Now I've got to distribute the square root of 6. So I'll multiply here. I got square root of 6 times 2. I cannot multiply those together because one is under the square root and the other is not. So I'm just going to have to write this one as 2 times the square root of 6. It's going to be positive. And then for the last part, I'm doing square root of 6 times negative square root of 6. What is square root of 6 times square root of 6? 6. It's going to be minus 6 because one of these is positive and one of them is negative. There. And so we wanted this to happen because what's going to happen with those two middle terms right there? They cancel each other out. That leaves us with just 4 minus 6. So we're going to have 8 times 2 minus the square root of 6 over 4 minus 6, which is negative 2. Technically, that will reduce a little further because you can reduce that 8 and that negative 2. We're just going to stop here because my main objective was to rationalize the denominator, mean get the square root out of the denominator, and I've done that here. Okay. The second thing is the one that's going to come in handy on a lot of the problems that they're going to give us. So let's look at some limit problems where we have to use this. Now, sometimes we may not be rationalizing the denominator. We might be rationalizing the numerator, actually, but the same principle applies. So what is the first thing we try every time on every problem? Plug it in. So we're going to try to plug it in. I'm okay with you doing this in your head instead of writing it out on paper, but I'm going to write it out to remind you that you need to do this every time. So I'm going to plug in 0. I'm going to get the square root of 1 minus 1 over 0. Square root of 1 is 1 minus 1. That gives us 0 over 0. Right? Perfectly okay if you do this in your head, but I'm writing it out to remind ourselves that this is the indeterminate form. So that tells us we got to do something else. So on a problem like this, we can't factor and cancel because we can't factor that numerator right there. There's nothing we can do with it. And when we see a square root, that is a sign that we might need to multiply by the conjugate. I'm going to write that out so we got that phrase written down. So if you hear me say that, we'll kind of know what we're talking about here. So let me rewrite this limit. We're going to have limit as x approaches 0 because our first attempt was a failure. Okay. And so when we're multiplying by the conjugate, we're concerned with the part that has the square root. So we're concerned with this. I'm going to put a set of parentheses around it. And I want to multiply by the conjugate, which means I'm just changing the sign in the middle. That's the only thing that changes. Okay, so everything else stays the same. I've got square root of x plus 1. I don't change that plus that's on the inside of the root. I got the 1 right here. The only thing that changes is I'm going to make this a minus right here. Okay, but can I just multiply the top? I cannot just multiply the top. I also have to multiply the bottom.
Wouldn't it be a plus sign or minus sign?
Yes, thank you. That's why I was getting funny looks. It's like, what do y'all not understand? But that was the funny looks. It should be a plus. Thank you. Okay, so mess that up. But everybody clear? This minus sign changes to a plus sign. That's the only thing that happens. We got to multiply on top and bottom here to make it equal to 1. All right. So we're going to do just like we did on that last problem where we were rationalizing, but only on the side you're trying to rationalize. So because it's not going to do you any good, really. You could take this x right here and multiply it by the stuff in this parentheses, but then you're just going to end up having to factor it right back out later. So don't do anything with the bottom. Only multiply the top together. You want to hold on to your limit notation because we have not plugged any numbers in yet. So we're still going to write limit as x approaches 0. And then we're going to multiply. So when I multiply the square root of x plus 1 times the square root of x plus 1, what do I get? Square root of 5 times square root of 5 is just 5. Or square root of 7 times square root of 7 is just 7. So square root of x plus 1 times square root of x plus 1 is just x plus 1. With no roots. Then I must multiply my square root of x plus 1 times the positive 1. You cannot multiply those things together because one's under the root, one's not. So you just end up with a positive square root of x plus 1. You can put the 1 out front if you want, but it's not necessary. Then you have to distribute your negative 1. So that's going to give me a minus square root of x plus 1. And then on the end, negative 1 times positive 1 gives me a negative 1. On the bottom, don't multiply it together. Just keep it factored. You can multiply it, but it's not going to help you. Any questions on that part? Now, the reason we chose the conjugate is because the middle terms are going to cancel. All right, that's the reason we chose the conjugate. In fact, after you've done a few of these, you might start just skipping even writing that middle part down because it's going to cancel every time. So this is going to leave us with the limit as x approaches 0 of x plus 1 minus 1 over x times square root of x plus 1 plus 1. Okay, what else do you see here that is helpful? There's some stuff that'll cancel, but there's a couple things that can cancel, but you got to do them in a specific order. The negative 1 and the positive 1 have to cancel first. Okay, so then that leaves you with the limit as x approaches 0 of x over x times square root of x plus 1 plus 1. Now what can cancel? The x on top can cancel with the x on bottom. You can't cancel it earlier because the positive 1 and the negative 1, like you got plus or minus signs in between. So you need to get rid of the 1s first, then the x's can go. Now, nothing's left in the top, but what's really still there?
1.
A 1, because there was like a 1 in front of that x right there. So now we've got the limit as x approaches 0 of 1 over the square root of x plus 1 plus 1. Okay, once something cancels, you can probably do direct substitution. So at this point, I can quit writing that limit as x approaches 0 because I'm plugging in a number. I've got 1 over the square root of 0 plus 1 plus 1. That is 1 over the square root of 1 plus 1. And I don't know what's happening here. I got 1/2 for that. Okay, questions? All right, let's do one more of these just to make sure we've got it. This one, I've got roots on the bottom. I've actually also got 2 roots, but we're going to do the same thing. So always, you don't necessarily have to write it down, but what's the first step we always do? Direct substitution. I'm going to get 0 on top. It's already looking bad. I got square root of 5 plus 0 minus square root of 5. That is going to be 0 over square root of 5 minus square root of 5, which is 0 over 0. That is indeterminate form. So I got to do something else, right? We figured that was probably going to happen there. So let me recopy this real quick, since my first attempt was a failure. And like I said, you can do that part in your head. All right, so I'm going to put me some parentheses around that square root of 5 plus y minus square root of 5. And I need to multiply by the conjugate. The only thing I change is that minus sign right there in the middle. So it's going to be square root of 5 plus y plus the square root of 5. And if I do that on the bottom, I must also multiply on top. Okay. Don't multiply the top together. You only want to multiply the part you're rationalizing together, because if you multiply the top part together, you're just going to have to factor it back out on the next step there. So, switch colors back. I got to keep writing that limit notation. It's a little annoying to write it, but on a free response question, it's got to be there. So the top, I'm just going to leave it alone. On the bottom, I've got to multiply square root of 5 plus y times square root of 5 plus y. What is that going to give that? What is that going to give me, Raleigh? Square root of 5 plus y times square root of 5 plus y. Okay. Michael?
5 plus y.
Just 5 plus y. Whenever you multiply a root by that same root, it just gets rid of the root because it's like you're squaring it, right? Then I got to multiply here. These are both underneath the square root, so you can multiply them together. But really, it's not going to matter because, like, if you multiply the 5 here, you're going to have 25 plus 5y. But on the next part, you're going to get minus the square root of 25 plus 5y. I'm okay with you guys just skipping that piece, because if you chose the conjugate correctly, those should cancel out every time. And then the last part, we got to multiply the square root of 5 times the square root of 5. Avid, what do we get when we do square root of 5 times square root of 5? 5, and it'll be a minus because it's a positive and a negative of that. Okay, again, I'm okay with you skipping those two middle terms, knowing that we chose the conjugate, so those would cancel out. So now what I'm looking at is y times square root of 5 plus y plus the square root of 5 over 5 plus y minus 5. So I have a positive 5 right here and a negative 5 right here. Those are going to cancel each other out. Here, that leaves me with the limit as y approaches 0 of y times square root of 5 plus y plus the square root of 5 over y. Y's can cancel out. This time, I don't really have to put a 1 on the bottom. You can if you want to, but you don't have to put the 1 on the bottom. And so now you can just go straight into direct substitution now that the y's are gone. So you're going to have the square root of 5 plus 0 plus the square root of 5. So that's square root of 5 plus square root of 5. How are we going to write that? What's that? 2 times the square root of 5. Because it's like you've got one root 5 and another root 5, so that's 2 root 5s together. Okay, questions? All right, that'll cover what you need for those like last few that we didn't know how to do either. So you still got about 10 minutes. Go ahead and keep working on that textbook assignment for me.